Hello and welcome to the webinar False Positives Are Wasting Your Time. I'm your host Tobias from testresults.io and I'm eager to show you the different problems with false positives in test automation that are still there today. So for that, let's directly start with the definition of what a false positive actually is. Whenever we talk about false positives, the idea is that there's a test result which indicates the presence of a condition incorrectly. So what does that actually mean? Let's look at an example that everybody can relate to. Like, there is a condition, do you have COVID-19? The actual truth is no. You do not have COVID-19 right now. But the test would say yes. This is a positive result. You are infected by COVID-19 at the moment of testing. That would be a false positive in every sense of its meaning. So let's look at a technology example of that. Let's assume we are testing the functionality to register a new user. And it actually works as expected. Nevertheless, the test tells you, yes, I found a bug. I cannot register a new user. That's again a false positive because we were looking for bugs and we found a bug where no bug exists. That is why we call it a false positive. That being said as a groundwork, let's switch over to see where are the false positives in today's test automation. So where do they root from? Typically, we have different phases of automation. One is the design phase, or typical phases of testing, actually. So in the design phase of testing, we work with test data, we define test data, we define where we get test data from, and we define how to use different test data and also anonymization and stuff like that. Then there's the second part in the design phase, which is the actual automation design. So that's the part where we automate those test cases. Then there's a second phase, which is called execution. You're running your automated test cases in a myriad of different environments. And last but not least, there's the reporting phase. So we are collecting all of the evidence, we are collecting all of the results and generate output. And as you already might have noticed from the caption wrong outputs, those are different routes, different sources of false positives. Let's start with a simple one at the bottom. In the area of reporting, because the reporting is driven by humans, there might be wrong outputs. You just created the wrong assert or the wrong log message or whatever. And for the executions, sometimes environments are available, sometimes they are not available. They might have the right version installed. They might have some dependencies missing. So there's a lot of different situations in which the environment can actually introduce false positives into your results. And then there is the part in the design phase of testing, where it's about test data and automation design. And let's look at the impact over time of all of these different kinds of sources of false positives. Because most of the time people just look at it and say yeah, it looks like that my environment is never available and that is number one source of my false positives, or as you sometimes call it, flaky results. Which might be true, but most of the time it's not. So let's look at the first one, reporting. So what we see with customers is that reporting is typically not such a big problem and it doesn't change over time. So if you got your reporting wrong in the beginning, you can fix that, and afterwards reporting is neglected as being a source of false positives. But there is a slight chance that you miss something, so it's still a slight chance that you get false positives based on your reporting, also later in time of the test. The second one is, we already talked about environments, right? we do have a feeling that the environments are never ready, and if you want to use them, they are occupied by somebody else, then they don't have the right dependencies installed. They do have a development version of our software under test installed already, and we still want to test against the productive version. So all of those are things that are pretty obvious, and that most of the time just takes a systematic approach to environment management. So what we see is a lot of false positives in the beginning, which is roughly around 20% of all of the false positives coming from environmental problems. But those are, from a technological point of view, easy to handle. There might be political reasons why it's not easy to stabilize testing environments, but from a technical point of view, you can nail all of those problems down and do have your scalable testing environments available with not much impact on false positives during your test automation. So it will come down below like 5%. Then there's test data. And we all know how complex test data is. But the thing is, the contribution to false positives decreases over time as well, as we are getting more and more used to the data, and we're getting better and better in handling the data and understanding what kind of data we need at which point in time. We're getting a lot better in handling those false positives. So we start with around 80% of all of the false positives coming from entering wrong data, like being it the wrong birth date, or being it the wrong transaction history in banking, or being it some setup like a new lead and you changed the wrong list type, stuff like that. So a lot of the false positive findings that we do have in the beginning nail down to a problem in the test data. And that is actually what most of the people perceive as root cause number one, is test data is not reliable, and therefore I do have flaky results, or I have false positives in my results. Which is true in the beginning, but if you look at it over the time, you will see that actually the contribution of test data flakiness, or of accessibility of test data, reduces to below 25%. We roughly talk about 20% around that for test data having impact on your false positives. So there's a last driver to false positive, which is the automation itself. And typically in the beginning, it's not taking part of all of your false positives that you do have during the execution. Why is that the case? Because typically if you automate it, and naturally you automate it as long as it is required so that it works without any false positivities, right? So you don't have flaky results in the beginning. You do the automation design, you execute the test case, you see, oh, there's something that I need to fix. You do the execution again, then there's something else you need to fix, then you do the execution again, and fix the last part of it. And afterwards it's stable, and you don't have flaky execution, so you don't have false positives because of your automation. And that shows you the impact over time, actually. In the beginning, as I already mentioned, a lot of the false positives is coming from test data and not from your automation itself, as you're stabilizing the automation before you're using it in production. That makes sense, right? Because test data is not stable, because it might come from production, or it might be generated, but it's not stable in the beginning, and your automation is stable in the beginning. But over time, there is an effect. Actually, the false positive rate, which is based on your automation, on how your automation behaves, or how your automation interacts with the system, is increasing. And it's getting above 70%. So it's 70% of the contribution to false positives is coming from the test automation itself. So you see it's going up and down in the bar. And that is because a lot of people have understood that there is maintenance required for test case automation. And then there are those cycles where you maintain it, and then everything is running again, and everything is non-flaky. You don't get false positives. You still get a few false positives, true, but there is somebody involved in that, taking care of that. And that is what you typically see. So what we see from our customers before we start working with them is that in the beginning, they struggle with test data, and they do have a lot of false positives because of incorrect data entered into the system under test. And we also see that they struggle with the automation over time. So in the beginning, everything is fine. They saw the new shiny demos from their vendors, and they also adopted to the best practices. Everything is working, it's stable. But then the tests are starting to rotten. That's the same, by the way, for unit tests. In the beginning, you have thousands of test cases, and they are brilliantly fine, but nobody's maintaining them, and therefore they are rotting, and they don't have any benefit anymore afterwards. So, what is the root cause for those two? And we just concentrate on test data and on test automation, because the other two are neglectable, to be honest. You can easily control them with technology. So for test data, as a source of false positives, there's always three different kinds of test data. One is already consumed, so it's not usable for your system anymore, but that is unexpected. Let's say you enter a new lead, and then you try on the next run, enter the new lead again. The same one, same email address, it will not work. System will throw an error message. You might not have handled that error message in your automation, or you have handled it and then show, hey, there's a bug in the system, I cannot register the new lead. So test data being consumed. Next one is test data is expired already. So you got your job of test data from production, and then you are trying to use that during your testing. And it works in the beginning, but suddenly you get a lot of false positives from your test data because data expired. Being it a transaction log that was rotated and is not valid anymore, or being it some credit card data that expired in the meantime. Stuff like that happens in real data, so those are actually the sources of false positiveness. And last but not least, that's always the case, you try to enter some data, but it doesn't exist yet. It might be that there is no case in the real world yet that is actually following what you did in your test automation, or it might already be deleted, or you use synthetic data and the data was not yet generated. The last one we cannot easily fix, because either we do have access to this kind of data, or we can generate that data, or it just doesn't exist. And then we need to adopt the automation design naturally, or see if that is actually no use case at all. So if we have a system that is in production for 10 years and we don't find a single tuple in the database that is actually representing the use case that we are currently testing, we need to ask ourselves, is that a valid use case that we actually need to test in an automated fashion? Always keep in mind we are talking about automated testing in here. So for the consumed and expired part, how do we handle that? It's pretty simple. We actually categorize the test data. So we are not looking for specific entries, but we do use a system where we allow to filter the data and we just give the categories. In the specific example, we say like, hey, I want to have a female in her 30s with a saving account with a history of 24 months in that saving account. So you see, I just need a data entry from the productive data that fulfills my f underscore 3xy underscore s24. That might be a different record of my productive data every single time, but it is a record that fulfills my criteria that is required for my testing workflow. And that is actually how you make sure that you don't consume the same data twice, or that you use the wrong data, and you can be as specific in those categorizations as you need it. I put in here as 3xy, saying like it's a female in her 30s. You can also say 35y, in the sense of like I need a female which is 35 years old, which is important for insurance testing, for example, or other ways, or other software actually that you are testing. So this specific approach is called categorized test data, and we are IDing the test data. So we give every single record in our productive data a unique ID based on the category that the data fits in. And that is how we solve flakiness for test data. That takes some time, and you remember the curve. We do have a lot of false positives in the beginning, but the false positives are going down to below 25%. Roughly 20% of all of the false positives are triggered by data. And we reach that actually by using this approach, by using data that is based on the category of information that I need to fulfill my workflow. So, for the automation, let's look at the most frequent automation traps that lead to false positives. Number 3 is you use recording. Think about that. I do have the screen here, that's a Microsoft Dynamics example, and I want to enter the information here in the item reference number. And if I'm using recording, it will collect my click on the item reference number field here in this table, and it will try to identify this somehow. And we do have a technical view over here now, and you'll see how the system will actually try to identify something. And the interesting part in this example is that this specific field actually has an ID. So any modern automation system that is doing recording will rely on that ID if it doesn't identify that that is a dynamic ID, which most of them don't. So it will use the ID BX8EE. But that is a dynamic ID. It might be that next time we are using the same form, the field is 3 below, or it's a different field. And you are not in control if you are using recording about that. And the worst that can actually happen is that the system assigns the same dynamic ID to a different field every one, which is viable because it's not guaranteed to have the same ID all the time. And that means your test automation actually is looking for the field with the ID BX8EE, and it's getting a random field more or less. So it's not ensured that you will get this field and can enter data here, but you'll get, for example, this field and enter your data in here. And afterwards you have a different result, and that's the perfect definition of a false positive, because apparently the system behaves differently, which is true, and which is also correct because we provided different kind of data. So it should behave different, it should actually deviate from what we expect. And therefore, do not use a recorder. It's doing so much underneath, based on a technical level, that you rather do it by hand than using a recorder. The second most frequent automation trap that I see with our customers, before they become our customers actually, is the typical wait, sleep, pause, whatever put in delay in your automation because the system didn't respond instantaneously, but it took like a second before the next page was shown, and you have no other way of waiting for that than putting in a sleep 5. So I want to wait 5 seconds before I continue with my automation. You have all of those elements tried, like is element visible on screen and stuff like that, but none of them worked, so you see a lot of those wait, sleeps in automation code these days. I mean, you can just go to GitHub and check the different automation repositories, those codes in there, and you'll find pause and sleep in all of them. I'm pretty sure if you look at your automations right now, you will find pause and sleeps as well. So that is one of the biggest actually drivers of flakiness, because if you say, I want to wait 5 seconds, there are two things. One is, what happens if your application needs 5 seconds and 1 millisecond to respond? I can tell you it will abort and it will give you a false positive. The second one is you don't know the implementation of this wait. If you say wait 1, which is pretty obvious in most of the cases, you see something like, I just needed to wait a little bit, so I wait a second. So it's wait 1. But there are coding languages and there are paradigms where it says like, if you only wait 1 second or even only 1 millisecond, the system assumes that you are doing something wrong, and all you want to do is currently wait and give a little bit of compute power back to the system. So it's not guaranteed that you wait exactly 1 millisecond or that you wait exactly 1 second. It is more or less like, hey system, I want to wait, I give you back the control and get back to me as soon as possible. But it's nowhere defined what the as soon as possible means. So you have integrated a kind of flakiness into the flakiness. So your system that you are testing might come back with this response in different times. And now your system that is testing is also returning in a not defined behavior. And that is leading to a lot of false positives. And there is a single way to solve that, Don't use wait, sleep, pause, delay, whatever synonym you can come up for with that in your programming language or in your automation tool, just don't use it. If you have to use it, there is a severe problem somewhere in your automation. And the number one most frequent automation trap is actually using IDs or UI automation IDs or XPaths to identify an element. And I showed you this, and most of the time it's always web testing that is coming with that stuff, but it's also like Windows native applications where UI automation is used or some kind of fancy set of properties that identify control uniquely, which is not true, and we all know it. The thing is, all of those systems rely on the fact that we didn't have enough compute power to actually simulate a user, how they actually work, so we tried to find some workarounds because we are all technical people, and the best approach was to use technical stuff. So we tried to identify controls meant for the user in a technical way, and that is broken by design. So let's look at that. The solution to all of those is visual steering. Visual steering is a recordable, technology-independent solution to the three most frequent problems in automation today. Exactly the three that I just showed you. And I want to give you, at the end of this talk, a little demo on how that actually works. So let's look at this simple workflow in a used car platform. You have to select the manufacturer in the make field, and you can select a few other properties, click on results, and if you click on results, you will actually see the results. So in this specific example, I selected Audi as a manufacturer and clicked on results, and you'll see I selected Audi as a manufacturer and get a few results. And what you noticed as well is just I showed you like, hey, I selected Audi as a manufacturer here, and Audi is selected as a manufacturer over here. If you're working with IDs, actually, those systems behave completely different. Those are the two different boxes. For you as a human, it is pretty obvious that, hey, they are to select the manufacturer. And that's actually what they do, so you are right. But from a technical point of view, they look completely different. If you take the first one, that is a select HTML element, and it has a nice ID which is called make. It even has name make. So you can identify that easily. It's in a div structure, but nevertheless, let's assume we don't need any of those passes. We just use the ID make, right? Now the second one seems to be something completely different. It's from a functional point of view, it's exactly the same. For you as a user, it is exactly the same. But from a technological point of view, if you look at that, it became an input now. And hey, it has a completely different ID. And it's a different type. Everything is different. Now it has a role of a combo box. So now you need to maintain two different versions on how to access the make field. And now let me quickly show you how that actually looks like in visual steering. So you have the screen over here, and with visual steering, you can just analyze the screen as it is. So you just click on computer vision, and the artificial intelligence is actually annotating the whole screen. And that works for native applications, for mobile applications, for desktop applications, for host applications, for text-driven applications, and also for web pages, as you see in here. What we identified is the different ways of interacting with the web page. So what we tell the system is like, hey, make is a drop-down. So we just tell it the functionality, right? Make, the business object make is something to select from. And it automatically identifies the corresponding drop-down, and that's it. We say save, and we can just save it. Let's go over to the test case designer, and we say, hey, I want to have the make, and I want to press on the result button, exactly what I told you before. And what we want to do is we want to select an Aston Martin, and if we click on results, we actually want to see that the result button disappears. That is visual steering, right? Exactly as you think. If you click on the result button as a human, you would expect that the result button disappears. And that is exactly how visual steering works. So that is the screen. We go over to the test case and execute this single step. What you will see now is that the system identifies the software under test, identifies the browser, selects the make field, identifies that, identifies is there Aston Martin? No, but it's drop down, can I scroll? I find a scroller, I can scroll, and now I can select Aston Martin. So all of that is done in a visual way. You don't need to click anywhere. You don't need to change it to adapt to the system, because the system understands exactly as you as a human would, the system understands how to interact with those elements. And now you see the make field over here. Typically, you would need to create now a new abstraction for that make field in your Selenium code or whatever you're using. And let's try that with visual steering. So technology-wise, it's completely different as we have seen. But from a human perception, you can still understand that, hey, I can select the manufacturer in here, right? So let's do that. We just change the manufacturer like you as a human would do and say, I want to select BMW, just because I decided so. And we run this step again, this time on this version of the screen. And it identifies the make, it identifies that there's a drop-down, it's looking for BMW, and it selects BMW, and that's it. You see, it's exactly the same control that we actually recorded beforehand is still able to control this area. And that, ladies and gentlemen, is visual steering, a technology that is in charge of your application. It is actually helping you to automate applications in the way that you would actually test them if you would do it by yourself. No IDs, no weights, no strange XPaths that you need to identify. And hey, we do have a recording that is reliable because it doesn't depend on IDs underneath or any XPaths. Ladies and gentlemen, that is visual steering. And if you're interested in more visual steering, just follow our channel, send me some DMs, or put your questions now in the questions field. This is live, so you'll get your answers directly in this chat. Thank you very much for your attention, and I hope we had a nice introduction to why false positives actually happen and why it's always important to understand that false positives is always a function against time. So your perception might be that your test data is all messed up, you will never be able to automate, and that is true in this specific amount of time. But over time, you learn how to handle your test data, and your bottleneck, number one, becomes your automation design. Because you're relying on non-reliable stuff. And that is something that you need to change now, because that allows you to be more productive, that allows you to save money, and that allows you to actually bring that saved money back into feature development. And that is what we're all looking for, to actually deliver better and more features to our customer. Once again, thank you very much for your attention.